Welcome dear learners. So now I am just going to brief about the starting of a arc lamp. Basically I am going to detail about the arc lamp power supply. So first we should know what is that arc lamp. So normally this is the arc lamp and inside this tube there is a anode and cathode. Inside the tube, I am not going about the details. Okay, so this one is big one is anode and that small one is cathode. Okay, and inside there will be noble gas with a slightly different pressure, lower than the atmospheric pressure, and there will be some gap in between these two electrodes. Okay, so naturally this anode will be connected to the positive end of the power supply and cathode will be connected the negative end of the power supply. Now here question is this: to start up this lamp, first the noble gas inside the bulb should get breakdown, and once it get breakdown, then the resistance between these two electrode will be very less, and with very low voltage the electron will try to flow, even though it's a high current, and the bulb will glow, the illumination will start. So here the challenge is to ignite. So if you want to ignite that, it's need around 20 kV pulse. Okay, and parallelly there should be one current source also. You know, current source there is very less voltage, means the current source has very low voltage. So if this high voltage ignition pulse appeared across the current source, then it may damage. So we should, that is the challenge basically. So we should do something so that while we are igniting the bulb using this high voltage pulse, that time this should not reverse feedback come to the current source. So that is the thing. So there are several ways you can do it, but in parallel arrangement you can do very well. You can give directly the high voltage pulse to the across this electrode, but that time we need a very reverse blocking diode, so that reverse breakdown, reverse peak inverse voltage of the diode should be in 20 to 30 kilovolt. At least you have to take double of that. If 20 kV pulse means we need 40 kV peak inverse, and parallelly this bulb will draw several amperes, around 20 to 30 ampere current. So the diode should have 20 ampere as well as this much PIV. So that diode is very rare and it is very costly. So to eliminate that, we have to do some different arrangement. So here main thing is we have to apply the pulse. Our job will become very easy if we can ignite the bulb using very high voltage. That means if the high voltage appeared across the anode and cathode, but it will not transfer to the terminal of the current source. If we can do that, then we can handle these things very easily. So let us simulate it. So I am using simple one PSIM. So you see here 1:1 transformer. We have to use some transformer. So this transformer, this secondary winding should be capable enough to draw the rated current, because once this resistance I have given instead of this xenon lamp, because in this particular software that xenon lamp model is not there. So that's why I used simple resistance instead of that xenon lamp. Okay, arc lamp. And this is the power supply we are using. It is around, it is a 20 volt. Not naturally current source will be very less voltage, and here the pulse, whatever I am giving, it is 10 kilohertz and 20 kV. So what basically I want to show in this, using this arrangement, that the high voltage will appeared across the resistor that we measured using this voltage sensor, and this is V2. Whereas while these things is happening, when the if you do this arrangement, then eventually the high voltage pulse will appear across the xenon, this arc lamp, whereas it will not appear across the current source. So this is in V1. So let us simulate it. So this V2 is the high voltage pulse. You see, V2 is 20 kV. It is coming. Now we have to see whether it is coming across the current source or not. No. So if you do this arrangement, then our job is simple and we can ignite the bulb very easily. So what is to be done? So you can take the standard current source. You can take one ideal transformer. The thing is, the secondary of this transformer is series with the current source. So the entire high current will flow through that. So the cross section of the wire should be sufficient enough to draw that current. And here you use a boost converter or any standard ignition transformer. So if you do that and apply this arrangement with proper protection, that I am not detailing here, I am telling very simply, but it involves several protections. So if you can do that, then you can very easily ignite the arc lamp, and you can, by your own knowledge and practice, you can develop a power supply. So this was the very brief discussion how to ignite a arc lamp using some standard current source and standard ignition coil. Thank you so much. Thanks for your patience.